this video we'll discuss the scalar product, or we can call this as a dot product. So if we have, for example, a dot b, this is actually written mathematically as a dot symbol b. So you have to multiply, or this is, you have to find the dot product of vector a and vector b. This is not simply as multiply, but remember this is vector, so there is a meaning of dot. What's the meaning of dot product or scalar product? Okay. Now, if we have a dot b, this means to say that you have to multiply. Okay. So it is the product of the magnitude of a. This is a. Remember our previous topic, finding the magnitude. So you have to find the magnitude of vector a, multiply it by the component of b. When we say component, remember b is a vector. If we have two components, if we have two axes, or we have two components, so you have to choose the component which is in the direction of a. We have a component of b parallel to a, or component of b perpendicular to a. So there are two components in reference with a. So therefore, you have to multiply the magnitude of a by the component of b which is parallel or in the direction to a. So for example, we have this vector a and we have vector b, and the angle in between is theta. So finding the product of vector a and b is actually finding this magnitude. So the magnitude is, we have, don't worry, take the absolute sign. Okay. Now this b, it has a component parallel to a, so we have this as the axis. We orient the axis here. In order to break this b into two components, we have these parallel components and we have the perpendicular. We are concerned with the parallel because this is in the direction. So therefore, remember, to find the components, you have to extend a line projecting towards this line. So we have this 90 degrees projection. Then the other component is here, but we are not concerned with this because this is perpendicular. We are concerned with the parallel because in the direction. So therefore, in this case, the magnitude of this b component parallel to a is b cosine theta. We use cosine because this is adjacent. Okay, so therefore, very simple. The product of a, the a dot b means the magnitude of a, without arrowhead means magnitude, remember. And this is the magnitude of b cosine of theta. So therefore, this one is actually, you are multiplying the two. That's it. That's the meaning of that product. Okay. Now, so therefore, we can use the absolute sign if you want to, or this one. Both of them are the same. Now, what will happen if we reverse that product? Suppose you are asked to find b dot b, reversing this dot product. So the a dot b results this one. What about the b dot a? What is the meaning of b dot a? So the b dot a means the product of the magnitude of b. So take note the difference, because we are concerned with b dot a. So it should be the magnitude of b multiplied by the component of a in the direction of b. So this time, a has now the component with respect to b. In this one, the b has the component with respect to a. Now this one, a, b, vector a should have the component with respect to b. When we say with respect, parallel and perpendicular. This one is parallel and this is the perpendicular. So looking back at this problem, so we have to orient the Cartesian along one axis should be lying along b, so that we can come up with the component of a parallel to b. So that's it. We have to use this as the one axis, perpendicular to that is the another axis. So therefore, a can now be resolved into two components. So we are concerned with the parallel. So therefore, this dotted blue arrow is actually the component of b, which is parallel to B. This vector B here, the red is the vector B, so we have to take the magnitude of that. And this one, we have also to take the magnitude of A component, then multiply it, that's it. So therefore, this is A sine or cosine because this is adjacent. And this will becomes the B dot A means the B magnitude of this multiplied by the component A cosine. It is just a matter of multiplying this one, this red color magnitude times this dotted blue. Similarly, in this opposite figure, we are multiplying the magnitude of A, the blue color, multiplied by the dotted red, which is the component of B, in the direction of A. So that's it. So therefore, okay, now look at the difference. Is there any difference with the A dot B or the B and the B dot A? Let's investigate. Remember, this is magnitude. So if this magnitude, this should be positive always. No direction. Scalar, this is scalar. This is also scalar. There's no involvement of I hat, Z hat, and K hat here because these are all magnitudes. This one is also scalar because there is no direction of the cosine of an angle. So therefore, practically, the A dot B is the same as the B dot A. This is actually the property of scalar product. When you reverse the product of the scalar, nothing to worry. Another important here is you should remember that the scalar product provides a scalar quantity. So be sure that the answer did not involve unit vector because an answer with unit vector signifies a vector. And this one, there should have no unit vector in the final answer, or else it is no longer a scalar. Okay? So the answer is pure, or it is a number with units. Okay, so let us have this formally the definition. The A dot B means the magnitude of A times the magnitude of B, then take the cosine. So very simple to analyze. Again, the A dot B or the scalar of A and B is the magnitude of A, take the magnitude of that times the magnitude of B times cosine. This angle should be what? The angle between these two vectors. Okay? Now, what's the purpose of this? Why is it we need to study the scalar product? Now, we need to study the scalar product because in the topic of physics, there are quantities that involves scalar product. For example, work done by force. Work done by force is actually, work is W. So, we will discuss it later as we go in our topic on physics. So, if you're asked what is work done by force, it is simply as the force that is. Force F is displacement. So if we have the force and that force was able to move the body, then work is done on that force, on that object. So therefore, work is W. So simplifying or finding the work done, just apply the principle of that product. So this is magnitude of F, magnitude of displacement is, and you have to take cosine. So the angle between the displacement and force should be given so that they can find the cosine of that angle. That's it. Okay? Other is we have, by the way, if this is 0, if the angle between them, what does it mean? If this theta is 0, it signifies that if S are parallel. So the cosine of 0, remember, when you use your calculator, the cosine of 0 is 1. So therefore, this simply as if is. That's why we define as work as the product of the force and displacement. If it is true only, if the angle between them is 0 because they are parallel. If not, then you have to use the cosine. Okay, we have also an application of this. The product is the electric potential energy of the electric dipole, because in electric dipole, when you study electricity, the energy of dipole is negative. Dipole moment, this is dipole moment actually, and it is a vector. That product of E E is electric field. Okay, so these are only few of the examples or applications of the that product. That's why we need to study the scalar product. Okay, now what are the scalar products of the unit vectors? Remember unit vectors, I hat, j hat, and k hat. What is I dot I? What is I dot I? So if you're asked what's I dot I, then you have to use the formula. Remember, the A dot B is A, magnitude of A, magnitude of B, then cosine of the angle between them. So remember that this is vector. Unit vector is a vector. This is another vector, but they are equal. So they have to take the dot product. So we can use the formula. It should be the magnitude of I as this vector, and the magnitude of this one, then take the cosine. So what is the magnitude of I? 1. Okay? Remember, unit vector, it has a magnitude of 1. Don't forget that. And this is also 1. Now, what's the angle between them? If this is I and this is I, so therefore they are parallel to each other, because they have the same unit vector. So the angle should be 0. What is cosine 0? 1. So you are multiplying 1 times 1 times 1. And the answer is 1. The cosine of 0 is 1. So the I dot I is 1. Okay. Now what is j dot j? Also 1. K dot k, also 1. Okay. Now what about, okay, so there were 1, we have k dot 1. Now what is I dot j? Still use the formula. You have the magnitude of I is 1. The magnitude of j is 1. So multiply the magnitude here, magnitude of j. Cosine of, what is the angle between them? What is the angle between the I hat and j hat? Remember, I is along x, j is along y. Directly. So therefore, the angle must be 90 degrees. What is cosine of 90? 0. If you multiply that 0 to any number, the result is always 0. So therefore, the dot product, if the angle between the two vectors, the dot product is 0. If the angle is 90, if they are perpendicular. If they are perpendicular, because the 270 provides also a perpendicular relationship with the other, and the cosine is also 0. So the all forces or all vectors that are perpendicular to other vector, the dot product is 0. So with that, the I dot k is 0. What else? J dot I, the reverse, is also 0. The reverse of k and I is also 0. Then the I and j and k, 0. The k and j is also 0. These are the unit vectors of a unit vector. So we have to remember this one, that the answer varies only from 1 and 0. The dot product of unit vectors are only, it's either 1 or 0. This can be negative. Okay, this can be negative 1. Why? Because if this is negative I hat, then the answer is negative 1. If both of them are negative, then the answer is positive. Okay, 1. But you will arrive 1 if you are finding the dot product of itself. For example, the dot of itself is 1. The I j dot j 1. Okay, but the I j dot j is 0. Okay, so suppose I have this vector ax, I hat, ay, j hat plus aj, k hat, and we have the vector b in terms of its component. Suppose we are asked to find the a dot b. What will you do? Now, similar in our previous video in finding the vector sum, simplifying this one is you have to substitute a and substitute b. Substitute a, this is a, and substitute b. And take note, this is dot product. So all you need to do is to remove the grouping symbol, is to distribute this by multiplication. So meaning you have to multiply ax I hat. Okay? This should be ax plus times bx. So we have to separate this, because ax is a scalar and bx is also scalar. So ax, bx, and the vector is I, and we have the dot I. So this dot product works only on vector. So it works normally in normal product for the scalar, but in vector, there's a meaning of the dot product. Because what is I? This is 1, remember? So later on we can eliminate this one or simplify this vector. So you have to emphasize the grouping symbol for the vectors. Okay, continue. Remember, in algebra you have to multiply each term of this to all terms of the other factor. So this one times this one. So we have ax, ay, okay, plus ax, by, I hat. You cannot reverse because this is I dot j, not j dot I. Anyway, they are equal, but you have to follow the order of distribution. So we have ai, I hat dot j hat. So we have again we have ax, bz, I hat dot k hat. So these are the three terms distributing the first term, but we still have this one 3 times again. Oh, okay, so hold on in your solution. So we have ay bx, okay, ay bx, and this is j hat dot I hat. Okay, continue. Ay by j dot j. What else? Ay bz j dot k. These are the three. So we have already 6. Now finally, the last term here should be multiplied each term also. So there are another 3. So all in all, we should have 9 terms after breaking the grouping symbol by multiplication. And this is AGBX, okay, K hat dot I hat. And we have AGBY, and we have K hat dot J hat. Then finally, we have AGBG, K hat dot K hat. Okay, so again, what are zeros? The zeros are the dot product that are 90 degrees to each other. So this is 90 degrees, 0. This is also 0. What else? This is also 0. This one is not. This one is 0. Okay. This one is also 0. This one is 0, but this one is not. So therefore, what is I dot I? This is 1. Okay. So this term will be cancelled. The 0 terms will be cancelled out. This one is also 1. And this is 1. So what will be the remaining values? We have ax bx times 1. Okay. And we have ay by times 1, or ignore. And we have az bg. So therefore, the dot product of a dot b in terms of its component is just what? Multiply its component. Multiply the component along x, multiply the component along y, multiply the component along z, then algebraic sum. That's the vector, or this is the scalar product or dot product of a dot b. So there are 2 formulas so far. In our previous slide, we understand that the a dot b is the magnitude of b times the magnitude of b times cosine of theta. So therefore, you can use that formula provided that you have the magnitude of a and you have the magnitude of b, then cosine of the angle theta is the angle between b. So therefore, if that 3 are given, then you can use the previous formula. But if your problem involves involvement of vector, finding the product is, you can use this formula simply as multiply. Look at this one. A vector b. If you have to take the a dot b, just multiply ax by bx. Okay. Ay by by. Az by bz. Then take the sum. Now, this is very important reminders that the dot product is a scalar product. So therefore, the answer should be a number without the presence of z hat, k hat. So therefore, remember, magnitude, all are magnitude. So therefore, there's no unit vector in the dot product to call it as scalar quantity. Okay, so therefore, if we equate the two, remember our previous, this one is what? The magnitude of A, this is it. the magnitude of B, then we have to take cosine. And this one is also equal to this. So therefore, in this case, we can solve for theta. So combining the two formulas, this one and the previous, actually a relation that can solve the angle between. So meaning, if the angle between the vectors is unknown, you can calculate it using this their value in terms of the unit vector by what? Inverse cosine. So because we are solving the angle, take note, if we divide both sides by AB, then this is the result. Then take inverse cos or arc cos cosine. So this is AX BX, AY BY, this is the value. So meaning this is A dot B. Then divided by the magnitude of B. So this is actually the formula in finding the angle between two vectors. Okay? That's it. Very simple. Let's summarize the formula. So therefore, talking about the product, if we have the vector A and vector B, and the angle is theta between them, then the dot product of that is AX BX plus AY BY plus AZ BG. If what? If this is expressed in terms of its unit vector. No need to have this angle if this is expressed already in terms of the angle, or in terms of unit vector, so that you can solve for the dot product. Another formula is AB cosine theta. So this is applicable if the magnitude of A, the magnitude of B, and the angle between them are given. So therefore, using this formula, depending on the given information of vectors A and B. That's it. So combining these two will provide what? Provide an angle. So you can calculate this angle by simply providing the vectors A and B in terms of its unit vector. We can always find the angle between them. Okay? So let's have an example. Suppose I have this vector z and vector h given 9 I hat, 3j hat plus k hat for z, I hat minus 6k hat for h vector. Take note, I hat, k hat. So j is missing. So when we say missing, it is not the unit vectors. Vector is j is missing. The magnitude is 0. So therefore, there is no magnitude along y-axis. So therefore, we have only 2. Okay, find the dot product. Then find the angle between them. Then sketch the graph. Okay, sketch the graph of the vectors z and h. By the way, there must be a sign here, arrowhead, to signify vectors. Anyway, we have this vector word. Solution is okay because the formula used is the in terms of components. So you take the product, okay? You have to multiply this. Remember the formula? The component of z along x and h along y, along z. So it should be 9 for the x component, and this is 1. So 9 times 1. Then plus negative 3 for z, but in h there's no y component, so this must be 0. Here is negative 3 multiplied by 0. Take note, this will become 0. Plus 8z, this is 1. And this is negative 6. So therefore, that's it. This is 0. Huh? Don't include this 1. This is 0. So this is 9 plus negative 3 equals, negative 6 equals 3. This is the answer to the problem. By the way, you have to use word units because in physics, there must be a unit. So in this case, there is no specified unit. So use unit as additional information. This one, because sometimes the vector is in force. Remember, there are many quantities that in a vector quantity. So there must be a unit. So force is a unit of in Newton is the unit of force, or poundal and so on. Dyne. Sometimes centimeter displacement is a vector, so centimeter meter, feet. So you have to use the unit. But this one, there's no unit, understood to have this unit. Now, the angle. Okay, the angle is, use the formula. Okay? The formula is inverse cos. When this is the dot product, actually, this value is equal to 3 already. And this one, what is G? This is the magnitude of G. Remember magnitude? Square root. So this is also its magnitude. So take square root of the square of its component. So all you need to do, by the way, no need to evaluate this one because we already calculated it here. So substitute it here. Take square root. This one is the magnitude of G. Do not forget the formula. 9 square. I include negative again. Okay na? 3 square and we have 1 square. This is the magnitude of G. Square root of this number, this is actually the magnitude of H. And we have only two terms here because G is missing. J is missing. So we have I square plus negative 6 square. Then simplify. Careful in simplification. So then you have to multiply this first. 3 divide the product. Then take inverse cos. Now, change your mode into degrees so that you have this degree mode. So, okay, so the angle between them is 86.02 degrees. This is the answer. Final question. Sketch the graph. How will you sketch the graph of the two vectors? Remember two vectors. Okay. So, do not forget to overlay the Cartesian. So, or the three axes is the x-axis, the y, the z. This is the origin. So, going to the right, positive, going upward, positive y, downward, negative towards you. Okay. In order to provide a drawing, so this is actually towards you or towards the video. Okay. Towards me. Negative. Towards you is actually positive. So, okay, sketch is do not draw, not necessarily drawn to scale. So, what is 9 I hat? Where is 9 hat? 9 hat. So, you have to be counting 9 units from 0. 9 units here. So, let us say this is 9 units. So, this is 9 I hat. This is it. This is the x component. Then, the y component is negative. So, what does it mean? What's the meaning of negative? What is the meaning of negative 3z hat? Okay, at this point, because we will connect this in the polygon, this should be downward. Downward. Because upward is positive, so this should be 3 counts of 3 units of scaling. Our scaling is downward is negative 3g hat. Let's see this one. 1, 2, 3. Okay. So, again, from origin, the positive 9 is towards right. Downward for the y component because negative. Now, what is k? So, take note, this is our endpoint. Towards me, or in the video, this video, is negative. But towards you is positive. So, therefore, towards you. Okay? Towards you. This is 1 unit only. Because this is k means 1. That's it. These are the 3 components of vector z. So, you have to connect this with a straight line. This is your g vector. And the 3 components are reflected. So, this is actually the sketch of the graph. This is how to picture out the vector in terms of 3 components. You have to use the box or the 3-dimensional components of coordinate. Now, what about the h component? So, h component is 1 unit positive. 1 unit positive. So, very small distance. This one. This is the y hat. Now, what is j? Because this is k. So, what is j? J is 0. So, therefore, you cannot move. Stay here. Stay there. Then, next is, where is the 6k hat? Is it towards me or towards you? Because this is negative, it should be towards me. Okay? Towards me. Do you understand? Because towards you is positive. Look at this z-axis. So you have to count 6 units. That's it. There is no y because this is 0y component. So where is your z vector? So the z vector should be constructed from the origin towards the tip of the last component. This is it. This is the graph or the sketch of the two vectors. Okay? So, if you have this value, illustrates this value, 9 units, 1 to 10, that's it. Now, where is the angle between these two vectors? Remember, the two angle vectors is this one, theta. So, therefore, the angle is, look at this one, this is the orientation depending on the slope of the lines. So, this is the angle, directly straight angle, or no, flat angle towards the, from the plane of this line is theta. So, how much is this theta? The answer is 87.02 degrees. That's it. It's hard to picture out the graph, especially the vectors, and also the angle. If you're asked to measure this one, how will you do it in actual? But in theory, we can easily solve the angle. Okay, that's the power of theory. We can provide the value with just an imagination. And this angle is actually an accurate angle. If you measure this one using protractor, okay, you will arrive the angle, but you have a large chance of having error in measurement. But this one is a precise answer. Okay, so I hope it's clear to you about the scalar product. As I've said, this is very important as we go on our discussion on physics. So for your activity, you are all encouraged to solve this one. Verify yourselves on how far you are from the scalar product. Thank you for listening. See you in the next video. Next video is the vector product or the cross product.